I told you before that there'd be a quiz next class, right? And so we're pretty much in the middle of lesson 3. And quarter 2 is going to end on January 24th. So the last day to turn in assignments is January 17th. But for this review, for next class, this review, all right, when you're solving for radicals, you're going to be doing radical expressions and graphical characteristics. So when you're solving for radicals, your goal is to get this term by itself. So that means I'm going to subtract 2 on both sides. Okay, so goal, get x by itself. Then square both sides. Then simplify, right? Simplify. So I get 5 square root of x. This goes away. Equals 12 minus 2 is 10. Divide both sides by 5. And I get the square root of x equals, sorry, where did I get 50 from? 10 divided by 5 is 2. I'm going to square both sides. Notice I'm using parentheses. And x equals 4. That's my final answer. Okay? For letter B, I don't have to do anything. Everything is under the radical. I got the radical by itself. So the index, or the root here, is 3. So that means I'm going to cube both sides. And then I'm going to simplify. So I'm cube both sides. Then I'm going to simplify. So I get this going away because of that exponent up there. I get 2x plus 1 equals 27. Subtract both sides by 1. Draw my line underneath. And I get 2x equals 26. Divide both sides by 2. And x equals 13. For the next part, performing the indicated operation, then simplify. I have the cube root of 3. The cube root of 4 times 18, or this equals the cube root of 72. Okay? And I go to my graphing calculator. (72) over x cubed. Look for that smallest y. And it looks like 9. I'm going to go down and make sure that's correct. And it looks like 9, which is paired with 2. Can't be 1 and 72. It's got to be 9. So this equals simplified to cube root of 9. Make sure you circle your answer so there's no confusion. For B, I'm going to multiply what's inside first. So that's going to give me 5 times 20, right? And I'm just going to go ahead and separate these out. And then a cubed times a times a cubed times a. And just put a little 1 there, right? And all you do with variables is you just count. So I have the square root of 100 times the square root of a to the 4th. And the square root of 100 is 10. A to the 4th over 2, or just 10a squared. And remember here, it's the power inside divided by the index outside. For that 4 over 2, the power inside divided by the index outside. Okay? Letter C, we're just combining like terms. So here's my like terms. Square root of 7. 2 plus 3 equals 5. And that's my final answer. Easy stuff. Next one, you have to simplify. So you have 3 times this radical simplifies to 3 square root of 2 plus 2. This radical simplifies to 6 square root of 2. Simplifying further, 3 times 3 is 9 square root of 2 plus 2 times 6 is 12 square root of 2, or in all 21 square root of 2. Next one, we're using FOIL. So first we have 6 and 1. So 6 times 1 is 6. Okay. The outers, we have 6 and square root of 7. So 6 times the square root of 7 times the negative square root of 7. That's a negative. So minus 6 square root of 7. I'm just going to bring this down so I can work with it, right? Then we have the inner, which is square root of 7, negative square root of 7, and 1. Negative square root of 7 times 1 is minus 1 square root of 7. And then we have the last, which is square root of 7, negative square root of 7 times negative square root of 7, which is positive 7. Now, combining my like terms, 6 plus 7 is 13, minus negative 6 minus 1, that's negative 7, square root of 7. Here's my final answer. If you didn't understand it, please go back and replay it because it's going to be on your quiz. The next one, we're squaring a quantity. So remember, when you're squaring a quantity, you're just multiplying it by itself. And we're going to use the same method. My suggestion is that you write it down. So we have FOIL. And I write the numbers down so it makes it easier for me to do what I need to do. So the square root of 10 times the square root of 10, that's going to give me 10, plus 3 times the square root of 10, that's 3 square root of 10, plus inner's right here, square root of 10 times 3 plus 3 square root of 10 plus 3 times 3, which is 9. Simplifying, 10 plus 9 is 19. 3 square root of 10 plus 3 square root of 10 is 6 square root of 10. And that's basically an overview of your quiz coming up. So I'm just going to stop it here so you don't have to go back and try to play through a whole video trying to get to how to practice these particular methods. And actually I can't stop it, so I have to keep going for your quiz part. So for number 3, please give the indicated graphical characteristics. So the function family here is not a radical. You have to be specific. If it's square root, you write square root radical. If it's a cube root, you write cube root radical. If it's fourth root, you write fourth root radical. So this is a square root radical. And I can tell because it does not continue past a certain point. It has a stopping point. It has a beginning, at least, or an end. One or the other. Okay? Now, the equation of the parent function for square root radicals is y equals the square root of x. Remember, for cube roots, y equals the cube root of x, and so on and so forth. Now, the domain starting at its starting point, my domain starts here. It starts at -1, -2, -3, -3, and it continues all the way over towards positive infinity. So my domain is -3, heart bracket, comma, infinity, parentheses. Now your range, a little bit different. It starts here at, let's say, 1, and then it goes all the way down to negative infinity. So from negative infinity to 1, from negative infinity up to 1, and it stops. Now, does it have zeros? Does this object have zeros? Has 1 0 at 2, so when x equals 2. So this x-intercept itself is 2, 0. Does it have a y-intercept? Yes, this is 0, negative, looks like 0.7. So 0, negative 0.7. Are there intervals where this is increasing? Is there a domain where this is increasing? No. This is always ever pointing down. It's not increasing at all. So it's the same as your domain. So from -3 all the way over to infinity, this is going in a downward direction. So from -3, it's decreasing. So there's no increase. So from -3 all the way over to positive infinity. Is there a maximum? Technically, no. But I tell you what, if you say that this is the maximum point, because technically it is, I will agree with you. So at -3, +1, typically we're referring to turning points when we speak of these maximums, but this is acceptable. Are there asymptotes? No. In behavior, as x goes towards the right, as x goes in a positive direction or positive infinity, the y values decrease. They go towards negative infinity. As x goes to the left, y goes to 1. Now, write an expression that is equivalent to this number. So I told you before to see if these parts would simplify. So what you're going to find is you could simplify this part. So I'm just going to take this apart. Square root of 2x over the square root of 49. This is a perfect square, so this becomes the square root of 2x over 7. That's your final answer. Okay? Write an expression that's equivalent to this next part. So the square root of 3x divided by the square root of 81, and we're just separating those. It equals the square root of 3x divided by 9. Final answer. Write an example of a radical equation that does not have a solution. Write an example of a radical equation that does not have a solution. X equals the square root of x equals some negative number. So that does not have a solution. So, for example, I can write the square root of x equals -5. This does not have a solution. It does not exist. And it has no real solution. So let's make a little note. No, does not have a real solution. It does have a complex solution, but not a real solution. Okay? Another example would be, say, the square root of x equals -23. Just does not have a real solution. Okay? I think that's it for what the quiz is going to look like. So I'll leave it at that.